There was a time before stars, before galaxies, before planets, oceans, or even atoms. A time when the entire universe was not filled with darkness, but with fire. Not ordinary fire, not flames like the ones humans gather around on cold nights. This was something far stranger, far more violent. A sea of unimaginable energy stretching endlessly in every direction. A universe so hot that matter itself could barely exist. A place where light and particles collided constantly in a blinding storm of motion. And somehow, from that chaos, everything you know was born. Your body, the earth, the stars above your head, even the quiet room around you tonight. All of it began inside that ancient cosmic fire. If you could travel backward through time, past the formation of Earth, past the birth of the sun, beyond the first galaxies, you would eventually arrive at a moment when the universe looked nothing like it does now. No spiral galaxies drifting through darkness, no glowing nebulae, no planets orbiting distant stars, only heat, an endless ocean of heat and light. The early universe was so dense and energetic that particles could not settle down long enough to form stable atoms. Electrons flew freely through space, while photons, tiny particles of light, scattered endlessly in every direction. The universe was opaque then. Even light itself could not travel freely. Imagine standing inside a storm so thick that visibility becomes impossible. Not because there is darkness, but because there is too much light, too much energy, too much motion. That was the newborn cosmos. And yet hidden inside that chaos were the seeds of everything that would come later. Tiny fluctuations, microscopic differences in density so small they almost seem meaningless. But gravity notices even the smallest imbalance. Over millions, then billions of years, those tiny irregularities slowly grew larger. Matter began gathering into invisible clouds. Those clouds formed stars. Stars gathered into galaxies. Galaxies connected into enormous filaments stretching across the observable universe. The vast cosmic web we see today may have started as fluctuations smaller than atoms, which means something extraordinary. The largest structures in existence were born from some of the smallest variations imaginable. And for a long time, scientists did not know whether evidence of this ancient fire still existed. But the universe kept a memory, a faint whisper from the beginning of time itself. Nearly 14 billion years later, that ancient light still fills the cosmos. It surrounds you right now. The cosmic microwave background is the oldest light humanity has ever detected. It is the cooled remnant of the universe's early fireball, stretched across billions of years as space itself expanded. Today, that ancient radiation is incredibly cold, only about 2.7 degrees above absolute zero. But once it blazed brighter than entire galaxies. When scientists first discovered this faint cosmic signal in the 20th century, it completely transformed our understanding of the universe. Suddenly, the Big Bang was no longer just a theory. The universe had left behind physical evidence of its fiery birth. And hidden inside that ancient light were tiny temperature fluctuations, subtle patterns revealing where matter once gathered in the young cosmos. Those tiny fluctuations eventually became galaxy clusters, stars, planets, and people. In a strange way, every human being carries the fingerprint of the early universe, because the atoms inside your body were forged through cosmic events set into motion by that primordial fire. The calcium in your bones, the oxygen in your lungs, the iron flowing through your blood. All of it traces back to stars that formed because the early universe cooled just enough for gravity to begin shaping matter into structure. Without that fiery beginning, there would be no galaxies, no Earth, no life quietly listening to the universe tonight. And perhaps the strangest part of all is this: the universe is still changing. Even now, space continues expanding silently in every direction. Galaxies drift farther apart. Ancient light stretches into longer wavelengths. The cosmos slowly cools as billions of years pass. The fiery universe of the past has become a colder and quieter place, but traces of that ancient heat remain everywhere. In starlight, in radiation, in drifting galaxies, and inside you. Sometimes when we look into the night sky, it feels as though space is empty, cold, silent. But the universe was not born in silence. It began in brilliance, a vast eruption of energy so powerful that it shaped everything that would ever exist. And tonight, after billions of years of cosmic evolution, that ancient fire still echoes softly through the darkness above us. The galaxies, planets, oceans, and even your body may all exist because of tiny imperfections smaller than an atom. At first, that idea sounds almost impossible. How could something so unimaginably small create an entire universe filled with stars, black holes, swirling galaxies, and living beings capable of wondering where they came from? And yet, modern cosmology suggests that this may be exactly what happened. Long before Earth existed, before the Milky Way formed, before the first stars illuminated the darkness, the universe was astonishingly smooth, almost perfectly uniform. After the Big Bang, matter and energy spread throughout the cosmos in every direction. Temperatures across space were nearly identical, differing by only tiny fractions of a degree. If you could have observed the young universe shortly after its birth, it might have looked like a glowing fog stretching endlessly through space. But hidden inside that smoothness were microscopic irregularities, tiny fluctuations in density. Some regions contained slightly more matter than others, not much more. In many cases, the differences were smaller than 1 part in 100,000, so small they almost seem meaningless. But in the universe, even the smallest imbalance can change everything. Gravity is patient. It does not rush. Over immense stretches of time, gravity slowly pulled matter toward slightly denser regions. Areas with more matter attracted even more matter. Little by little, those tiny fluctuations began growing larger. What started as invisible ripples eventually became enormous clouds of gas stretching across space. Those clouds collapsed into stars. Stars gathered into galaxies. Galaxies merged into clusters. Clusters connected into vast filaments forming the cosmic web itself. Every grand structure in the universe may trace its origins back to tiny imperfections present in the earliest moments of existence. Without those fluctuations, the universe might have remained smooth forever. No stars would have formed. No planets would orbit distant suns. No chemistry complex enough for life would exist. The cosmos would be a cold, empty sea of evenly distributed particles drifting endlessly through darkness. In a strange way, imperfection made existence possible. And scientists have actually seen evidence of these ancient fluctuations. When astronomers study the cosmic microwave background radiation, the oldest light in the universe, they observe tiny temperature variations scattered across the sky. These fluctuations appear as faint patterns in the afterglow of the Big Bang. They are incredibly subtle, differences of only millionths of a degree. But those tiny temperature differences reveal where matter was slightly denser in the young universe. They are essentially a map of the universe's earliest seeds of structure, a snapshot of creation in progress. Looking at those ancient patterns is almost like seeing the universe dreaming of galaxies before galaxies even existed. And what makes this even more astonishing is that these fluctuations may have originated from the quantum world itself. In the earliest fraction of a second after the Big Bang, the universe underwent a brief but extraordinary event known as cosmic inflation. During this period, space expanded faster than the speed of light, stretching tiny quantum fluctuations from microscopic scales to cosmic sizes. Quantum fluctuations are strange by nature. At the smallest scales, reality is never completely still. Particles and energy constantly flicker with uncertainty. Tiny variations appear and disappear continuously within the quantum fabric of existence. Normally, these fluctuations remain trapped within the microscopic world. But inflation changed everything. As space expanded enormously in an instant, those tiny quantum ripples were stretched across the universe itself. The smallest scales became the largest structures imaginable. This means galaxies may ultimately exist because of quantum events smaller than atoms. The night sky itself may have been shaped by fluctuations emerging from the strange uncertainty of the quantum realm. And somehow, billions of years later, those ancient ripples led to oceans, forests, mountains, and conscious beings capable of staring upward in wonder, including you. The atoms inside your body were assembled within stars born from those early density fluctuations. Every heartbeat, every breath, every thought happening quietly tonight is connected to events that began near the birth of time itself. You are not separate from cosmic history. You are part of its continuation. And perhaps there is something deeply beautiful about the fact that perfection was never required. The universe did not emerge from flawless symmetry. It emerged from tiny irregularities, tiny asymmetries, tiny imperfections. Those slight imbalances allowed matter to gather. Gathering allowed stars to ignite. Stars created heavier elements. Those elements formed planets. Planets eventually became homes for life. Even the carbon in your cells and the oxygen you breathe were forged in stars that only existed because of ancient fluctuations in the young universe. In many ways, existence itself is the story of small things becoming vast. A tiny ripple becoming a galaxy, a tiny imbalance becoming a solar system, a tiny planet becoming a place where living creatures wonder about the stars. And tonight, somewhere across the observable universe, gravity is still continuing this process. New stars are forming inside drifting molecular clouds. Galaxies continue merging slowly in silence. Matter flows along immense cosmic filaments, stretching millions of light years across space. The ancient fluctuations from the dawn of time are still shaping reality even now. The universe is not frozen. It is evolving constantly. And all of it began with tiny differences, almost too small to imagine. Sometimes when we think about the cosmos, we imagine gigantic explosions, colossal black holes, or galaxies colliding in dramatic displays of energy. But the deeper truth may be quieter than that. The universe changed forever because of tiny fluctuations hidden within ancient light. Small imperfections that gravity patiently transformed into everything we know. The stars above you tonight, the earth beneath your feet, and the atoms quietly drifting through your body may all exist because the early universe was not perfectly smooth. The light around you feels ordinary, soft lamps glowing in the corner of a quiet room, moonlight slipping gently across the floor, the pale shimmer of distant stars hanging silently above the earth. But hidden beneath all of that familiar light is something far older, something ancient beyond imagination. At this very moment, invisible light from the birth of the universe is quietly passing through your room. It moves through the walls, through the air, through your body itself. You cannot see it with your eyes. You cannot feel it against your skin. And yet it has been traveling across the cosmos for nearly 14 billion years. Long before Earth existed, before oceans formed, before the first stars lit the darkness, this ancient light had already begun its endless journey. Tonight, while the world sleeps peacefully beneath the stars, you are surrounded by the oldest light in existence. And perhaps the strangest part of all is that this light is not coming from somewhere far away. It is everywhere. In every direction across the sky, the universe glows with a faint, invisible whisper known as the cosmic microwave background. Scientists often describe it as the afterglow of creation itself, a fossil of light, a silent memory from the moment the universe was still young. To understand why this ancient glow exists, we have to travel backward through time to an era when the cosmos looked nothing like it does today. There were no galaxies drifting through space, no planets orbiting stars, no black holes hidden inside giant spirals. The universe was once a seething ocean of energy and particles compressed into unimaginable density and heat. In those earliest moments, everything was so hot that light itself could not travel freely. Photons, the tiny particles of light, were trapped inside a dense fog of charged particles, constantly colliding and scattering in every direction. The universe was bright beyond comprehension, yet strangely opaque, like standing inside an endless storm of fire where no beam of light could move more than a tiny distance before crashing into something else. For hundreds of thousands of years, this cosmic fog filled all of existence. Then, slowly, as the universe expanded, everything began to cool. Temperatures dropped, particles lost energy, and eventually, something extraordinary happened. Electrons combined with atomic nuclei to form the first stable atoms, mostly hydrogen and helium. Suddenly, the fog cleared. For the first time in cosmic history, light could travel freely across space. Those first liberated photons rushed outward in every direction, and they are still traveling today. That ancient radiation never disappeared. It simply stretched as the universe expanded. Over billions of years, the wavelengths of the light became longer and cooler, transforming from brilliant visible light into faint microwaves invisible to human eyes. Now the temperature of this ancient glow is only about 2.7 degrees above absolute zero, a cold whisper left behind by a once blazing universe. Yet despite its faintness, the cosmic microwave background fills every corner of space. No matter where you look, this ancient light surrounds you. When scientists first discovered it in 1965, they were not even searching for it. Two radio astronomers named Arno Penzias and Robert Wilson were attempting to eliminate strange background noise from a large antenna. No matter what they tried, the faint signal remained. At first, they thought the interference might come from faulty equipment. Even pigeons nesting inside the antenna were blamed. But eventually, scientists realized something astonishing. They had accidentally detected the oldest light in the universe, a signal arriving equally from all directions across the sky, proof that the cosmos truly had a hot beginning. That discovery transformed modern cosmology forever, and even more remarkably, this ancient light is not perfectly smooth. If scientists map the temperature of the cosmic microwave background with incredible precision, tiny fluctuations appear. Differences smaller than a fraction of a degree. Minute ripples frozen into ancient light. These tiny irregularities may seem insignificant, but they changed everything. They were the seeds of galaxies. Regions that were ever so slightly denser than their surroundings began pulling matter inward through gravity. Over billions of years, those tiny fluctuations grew larger and larger. Gas clouds formed, stars ignited, galaxies emerged, clusters assembled, and eventually planets, oceans, mountains, forests, and human beings appeared. Everything you have ever known may trace its origins back to those microscopic imperfections hidden inside ancient light, even your own existence. The atoms within your body were shaped by stars that formed because of those primordial ripples. In a sense, your life began long before Earth itself existed. And tonight, as you lie quietly beneath the darkness, some of those ancient photons continue streaming silently through the cosmos around you. Many have traveled uninterrupted for nearly 14 billion years, passing galaxies, crossing cosmic voids, drifting through expanding space itself. Only now, after an unimaginable journey, a tiny fraction finally reaches Earth. Some pass harmlessly through the atmosphere, some are captured by scientific instruments, and some are moving through your room right now. Ancient messengers from the dawn of time. There is something strangely comforting about that thought. The universe often feels impossibly vast and distant, but this ancient light reminds us that we are deeply connected to the cosmos, not separate from it, part of it. Every breath you take, every atom inside you, every heartbeat in the quiet darkness belongs to the same universe that once glowed like fire. And even now, the ancient glow remains, soft, invisible, endless. A silent ocean of memory stretching across all of existence. If you're still awake, drifting through the cosmos tonight, gently subscribe and continue this peaceful journey through the universe with me. The universe often appears clean and empty from a distance. The stars shine like sharp points of light. Galaxies spiral gracefully through darkness. Planets drift silently around distant suns. But hidden within the vast spaces between stars is something far more delicate. Dust. Tiny grains floating endlessly through the cosmos. At first glance, cosmic dust may seem insignificant, almost invisible, like faint smoke drifting through space. And yet these microscopic particles may eventually become oceans, mountains, or even living creatures. Every grain carries the potential for worlds. Tonight, as Earth turns quietly beneath the night sky, immense clouds of cosmic dust are drifting through the galaxy around you. Some are illuminated by nearby stars, glowing softly like celestial fog. Others remain hidden in darkness so deep that even light struggles to escape. Inside these silent clouds, the story of creation quietly continues. Cosmic dust is made from the remains of ancient stars. Long ago, massive stars lived brilliant but short lives, burning enormous quantities of hydrogen deep within their cores. As they aged, they forged heavier elements through nuclear fusion. Carbon, oxygen, silicon, iron. The very ingredients that now exist inside planets, oceans, rocks, and living bodies were once created in the hearts of stars. When those giant stars finally died, many exploded in violent supernovae, scattering their contents across space. Immense waves of energy hurled newly formed elements into the galaxy. And from those stellar ashes, cosmic dust was born. Tiny grains, smaller than grains of sand, drifted outward into interstellar space, carried by invisible currents through the Milky Way. For millions of years, sometimes billions, this dust wandered through darkness, cold, silent, weightless. Yet over time, gravity slowly began gathering these particles together. Inside enormous molecular clouds, dust and gas accumulated into dense regions where matter became increasingly compressed. As gravity pulled inward, temperatures rose. The cloud began collapsing under its own weight, and eventually, deep within the center of the collapsing cloud, something extraordinary happened. A new star ignited. A sun was born. Around this newborn star, leftover dust and gas formed a rotating disk. Inside that swirling disk, tiny dust particles collided constantly. At first, the collisions were gentle. Small grains stuck together through static forces and fragile chemical bonds. Minute particles became pebbles. Pebbles became rocks. Rocks merged into enormous bodies. Over millions of years, entire planets emerged from drifting cosmic dust. Mountains formed. Volcanoes erupted. Oceans condensed from vapor. The Earth itself began as a cloud of scattered particles, orbiting a young star nearly 4.5 billion years ago. Everything familiar around you today once existed only as dust floating through space. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it originated inside ancient stars that died long before the sun existed. In a very real sense, your body is made from recycled stardust. And perhaps the most astonishing part of all is that cosmic dust does more than create stars and planets. It may also help create life itself. Within cold interstellar clouds, dust grains act like tiny chemical laboratories. Atoms settle onto their surfaces and combine into increasingly complex molecules. Scientists have discovered water molecules forming on dust grains in deep space. Organic compounds have also been detected drifting between stars. Some molecular clouds contain alcohols, carbon chains, and even ingredients associated with amino acids, the building blocks of proteins. The chemistry of life may begin long before planets are even born. In the darkness between stars, nature quietly experiments with complexity. Over immense spans of time, these molecules become incorporated into forming worlds. Comets and asteroids rich with water and organic material may deliver these ingredients onto young planets. Perhaps this is how Earth received some of the raw materials necessary for life. And perhaps the same process is happening elsewhere across the galaxy tonight. Somewhere beyond our solar system, distant clouds of dust may already be forming future oceans, future skies, future forests, or perhaps even future civilizations, gazing upward and wondering about their cosmic origins. The universe creates worlds slowly and patiently. Nothing appears rushed. A star may take millions of years to fully ignite. Planets may require hundreds of millions more before oceans stabilize and continents settle. Life itself emerged gradually across Earth's ancient surface through countless tiny steps unfolding over unimaginable periods of time. And all of it began with drifting dust. When astronomers observe giant nebulae through powerful telescopes, they are often witnessing these processes in motion. The glowing pillars inside the Eagle Nebula contain dense clouds where stars are actively forming. The beautiful clouds of the Orion Nebula cradle thousands of young stars wrapped in dust and gas. These regions appear peaceful from afar, but deep inside them, gravity, radiation, and chemistry continuously shape new generations of worlds. The cosmos is never truly still. Creation is happening constantly. Even now, somewhere in the Milky Way, grains of dust are gathering together inside collapsing clouds. Future planets may already be taking shape in darkness we cannot yet see. Future oceans may already exist as frozen molecules drifting silently through space. And perhaps somewhere, far beyond Earth, living creatures are breathing atoms that once belonged to stars just like ours. There is something strangely comforting about this endless cycle. Stars create the elements. Stars die and scatter them. Dust forms new stars and planets. Life emerges from those worlds, and eventually everything returns once more to the cosmos. The universe continuously transforms itself. Nothing is truly separate. The mountains beneath your feet, the oceans stretching across Earth, the cells inside your body, all belong to an ancient cosmic process billions of years old. Tonight, while you rest beneath the quiet glow of the stars, invisible dust still drifts across the galaxy. Silent grains crossing unimaginable distances through darkness. And within those tiny particles rests the possibility of future suns, future worlds, and perhaps future life waiting patiently to awaken. When we look up at the night sky, the universe can seem random. Stars appear scattered carelessly across the darkness. Galaxies drift like isolated islands, floating through an endless cosmic sea. The emptiness between them feels vast and disconnected. But the universe is not random at all. Hidden beneath the visible cosmos lies an immense structure so enormous that the human mind struggles to fully comprehend it. Galaxies are not scattered aimlessly through space. They travel along colossal, invisible filaments stretching across the universe like glowing highways woven through darkness. This immense structure is known as the cosmic web, and it may be the largest pattern in existence. Tonight, while you rest quietly beneath the stars, you are living inside this vast cosmic network. Our own galaxy, the Milky Way, is only one tiny thread woven into an unimaginably larger structure extending across billions of light years. If we could somehow leave Earth behind and travel far beyond the stars, beyond the Milky Way itself, the universe would slowly begin to reveal its hidden architecture. At small scales, galaxies appear isolated, but from far enough away, an astonishing pattern emerges. Galaxies gather into clusters. Clusters connect through enormous filaments. Between these filaments lie gigantic voids, almost completely empty of galaxies. The result resembles a vast three-dimensional web stretching across the cosmos. Some scientists compare it to the structure of neurons inside a brain. Others compare it to soap bubbles or roots spreading through soil. Yet nothing on Earth truly captures its scale. These cosmic filaments span hundreds of millions of light years. They contain immense rivers of galaxies, gas, dark matter, and energy, flowing slowly through space over billions of years. And perhaps the strangest part of all is that most of this structure is invisible. The cosmic web is held together largely by dark matter. Dark matter cannot be seen directly. It emits no light. It reflects nothing. And yet its gravity quietly shapes the universe on the largest scales imaginable. Scientists believe dark matter outweighs ordinary visible matter by more than 5 times. Without it, galaxies might never have formed at all. In the early universe, tiny fluctuations left behind after the Big Bang created slightly denser regions where dark matter began gathering. Gravity slowly amplified these regions over billions of years. Invisible scaffolding emerged across the cosmos. Ordinary matter followed these gravitational pathways, collecting along the dark matter filaments like water flowing through enormous cosmic rivers. Eventually, galaxies formed along these hidden structures. Stars ignited, clusters assembled, and the cosmic web slowly evolved into the magnificent architecture astronomers observe today. Even now, galaxies continue moving along these invisible highways. Nothing in the universe is truly standing still. The Milky Way itself is traveling through space at incredible speed. Our galaxy belongs to a small collection called the Local Group, which includes the Great Spiral Galaxy Andromeda Galaxy and dozens of smaller galaxies orbiting nearby. But even the Local Group is only a tiny component of a far larger structure. Entire galaxy clusters drift slowly toward massive regions of gravity, where countless galaxies gather together across the cosmic web. The motion is almost impossible to notice within a human lifetime. Yet across billions of years, galaxies migrate through the universe like leaves floating along invisible currents. Sometimes these movements lead to spectacular encounters. When galaxies travel too close together along cosmic filaments, gravity begins distorting them. Spiral arms stretch outward, gas clouds collide, bursts of star formation ignite, and eventually, galaxies may merge completely. Far in the future, the Milky Way and Andromeda are expected to collide in a slow cosmic dance lasting billions of years. Not as a violent explosion, but as an intricate gravitational ballet unfolding gradually across deep time. Stars will mostly pass harmlessly by one another due to the enormous distances separating them. But the shapes of both galaxies will transform forever. All because galaxies follow pathways shaped by the cosmic web itself. The vast empty voids between filaments are equally mysterious. Some cosmic voids span hundreds of millions of light years, with remarkably few galaxies inside them. If you stood within one of these immense voids, the night sky might appear far darker than anything visible from Earth. Entire regions of the universe contain almost nothing at all. And yet even these empty expanses help shape cosmic evolution. Matter slowly flows away from voids and gathers into denser filaments and clusters. The universe behaves almost like a living system, balancing gravity and expansion across unimaginable distances. Modern telescopes and computer simulations have allowed scientists to map portions of this hidden structure with increasing detail. The results are breathtaking. Galaxies form glowing chains across space like strands of luminous silk. Immense superclusters connect through delicate bridges stretching across the darkness. Everything appears interconnected. Even our own place within the cosmos becomes part of something far grander than earlier generations ever imagined. Human beings once believed Earth stood at the center of existence. Later we learned Earth orbits the Sun. Then we discovered the Sun is only one star among hundreds of billions within the Milky Way. Now we understand that even galaxies themselves belong to a much larger cosmic network extending across the observable universe. And still, the full structure may stretch far beyond what we can ever see. The cosmic web also carries a strange sense of beauty. Despite the immense violence of black holes, supernovae, and colliding galaxies, the universe organizes itself into patterns of astonishing elegance. Gravity quietly weaves matter together over billions of years, sculpting filaments, clusters, and glowing rivers of galaxies across the darkness. It is as though the cosmos possesses its own hidden rhythm, a silent architecture unfolding slowly through time. And within that enormous structure, there is something humbling about realizing that Earth is only a tiny point suspended inside one small galaxy, traveling along one filament among countless others. Yet somehow, within this immense cosmic web, conscious beings emerged, capable of observing the universe itself. Atoms forged inside stars assembled into living minds that now gaze outward, asking questions about the cosmos. In a strange way, the universe became aware of its own structure through us. Tonight, while cities sleep and stars shimmer quietly overhead, the cosmic web continues stretching across the darkness beyond human sight. Galaxies drift along invisible highways. Gravity shapes enormous rivers of matter. Clusters slowly gather beneath the pull of unseen forces. And far above our small blue world, the universe continues weaving its endless luminous network through the silent depths of space. The universe is filled with things we can see, glowing stars scattered across the night sky, nebulae shining softly in distant clouds, galaxies spiraling gracefully through the darkness. But some of the most powerful forces in existence remain completely invisible. Hidden deep within the hearts of galaxies are objects so strange, so extreme, that even light cannot escape them. Black holes, silent regions of space where gravity becomes unimaginably intense. For many years, black holes were imagined as cosmic monsters wandering through space, swallowing everything nearby like giant vacuum cleaners. But the truth is far more fascinating. Black holes are not merely destroyers. In many ways, they are architects. Invisible sculptors quietly shaping the evolution of entire galaxies across billions of years. Tonight, while you rest beneath the stars, one of these hidden giants lies at the center of our own galaxy. Deep inside the core of the Milky Way rests a supermassive black hole known as Sagittarius A star. It contains the mass of millions of suns, compressed into a region smaller than our solar system. And yet, despite its unimaginable power, it remains almost completely invisible. We cannot observe the black hole directly. Instead, astronomers detect its presence by watching how stars move around it. Near the galactic center, stars race through space at enormous speeds, orbiting something hidden from view. Only an object with immense gravity could control their motion. The black hole reveals itself not through light, but through influence. And our galaxy is far from unique. Scientists now believe that nearly every large galaxy in the universe contains a supermassive black hole at its center. Some are millions of times more massive than the Sun. Others contain billions of solar masses. These invisible giants quietly reside inside galaxies across the cosmos. But perhaps the strangest discovery of all is that black holes and galaxies appear deeply connected. The size of a galaxy's central black hole often matches the size of the galaxy itself. Larger galaxies tend to host larger black holes. This suggests something extraordinary. Black holes may help regulate how galaxies grow and evolve. At first, this idea seems almost impossible. How could something relatively small compared to an entire galaxy influence structures spanning hundreds of thousands of light years? The answer lies in energy. When gas, dust, or stars drift too close to a black hole, they do not immediately disappear. Instead, material spirals inward, forming an extremely hot, rotating disk around the black hole called an accretion disk. As matter accelerates and compresses, enormous amounts of energy are released. Sometimes this process creates brilliant quasars, visible across billions of light years. Other times, it launches colossal jets of charged particles, blasting outward at nearly the speed of light. These jets can stretch for millions of light years beyond the galaxy itself. Invisible black holes suddenly become engines powerful enough to reshape entire cosmic environments. The jets heat surrounding gas and push matter outward through the galaxy. This affects star formation in profound ways. Stars are born when cold gas clouds collapse under gravity. But if black hole activity heats or disperses that gas, star formation slows down or even stops entirely. In this way, black holes act like cosmic regulators. Too much star formation could rapidly consume a galaxy's gas supply. Too little star formation would leave galaxies dark and empty. The black hole helps maintain balance, an invisible force quietly shaping the destiny of billions of stars. Astronomers now believe this process plays a crucial role in galaxy evolution across the universe. Without black holes, galaxies might grow uncontrollably large or behave very differently than the structures we observe today. In a strange way, galaxies and black holes seem to evolve together, like partners in a slow cosmic dance. The universe often builds harmony from extremes. And black holes are among the most extreme objects known to science. Near a black hole, gravity becomes so intense that space and time themselves begin to distort. Einstein's theory of relativity predicted this long before black holes were directly observed. Time slows near intense gravity. Light bends around massive objects. Distances themselves become warped. A black hole is not simply an object sitting in space. It changes the very fabric of reality around it. At the boundary known as the event horizon, escape becomes impossible. Beyond that invisible edge, all paths lead inward. Even light cannot return. And yet, despite their terrifying reputation, black holes are surprisingly quiet most of the time. Many remain dormant for millions of years, silently resting within their galaxies. The supermassive black hole inside the Milky Way is currently relatively calm. If it suddenly became highly active, the center of our galaxy could blaze with extraordinary radiation, visible across immense distances. But tonight, Sagittarius A star rests quietly in darkness, while stars continue orbiting peacefully around it. There is something strangely beautiful about that silence. A hidden giant sitting motionless beneath the glowing heart of our galaxy. Invisible, ancient, patient. Black holes also help reveal the strange interconnectedness of the universe. The same gravity that pulls an apple toward Earth governs the motion of galaxies around supermassive black holes. The same physical laws shaping tiny particles influence cosmic structures spanning millions of light years. Nature repeats patterns across vastly different scales, And black holes may hold clues to some of the deepest mysteries in physics. At their centers, our current understanding of space, time, gravity, and quantum mechanics begins to break down. Scientists still do not fully understand what happens inside them. Some theories suggest information may somehow survive. Others propose hidden connections between black holes and the quantum structure of the universe itself. These invisible objects continue challenging human understanding. The more we learn about black holes, the stranger and more fascinating they become. Not merely cosmic destroyers, but creators of order, regulators of galaxies, engines shaping the universe on enormous scales. And tonight, as Earth drifts quietly through the Milky Way, our galaxy continues circling around its own hidden center. Far beyond the stars visible overhead, Sagittarius A star waits silently within the darkness. Invisible gravity guides the motion of countless suns. Ancient forces shape rivers of gas and dust. Galactic structures slowly evolve across billions of years. And deep inside the quiet heart of the cosmos, black holes continue sculpting the universe without ever being seen. For an unimaginably long time after the Big Bang, the universe was a place without stars, without galaxies, and without any visible light shining through the darkness. Space itself already existed, expanding quietly in every direction, but the cosmos had not yet awakened. There were no glowing spiral galaxies drifting through the void, no planets circling distant suns, no warm sunlight touching oceans. Only an immense darkness, filled with cooling gas, stretching endlessly across the young universe. It is difficult to imagine such a reality because every night sky we have ever known contains stars. Human history unfolded beneath their glow. Ancient civilizations navigated by constellations. Stories, myths, and dreams were written under starlight. Yet there truly was an age when the cosmos remained completely dark, waiting patiently for its first light to appear. This forgotten era is often called the Cosmic Dark Ages. After the universe expanded and cooled enough for atoms to form, most of space became filled with neutral hydrogen gas. Light from the fiery beginning could finally travel freely, creating the ancient cosmic microwave background that still surrounds us today. But after that first light faded and stretched across expanding space, darkness returned once again. The universe entered a long, quiet period. During this age, gravity worked slowly and silently. Tiny fluctuations left behind from the earliest moments of existence began pulling matter together. Regions with slightly more matter attracted more gas over millions of years. Little by little, invisible clouds grew denser. Gravity patiently shaped the future architecture of the cosmos. Nothing dramatic happened quickly. The universe moved with extraordinary patience. Across enormous stretches of darkness, massive clouds of hydrogen drifted together under their own weight. As they collapsed inward, pressure and temperature slowly increased deep inside these growing clouds. Eventually, some regions became so hot and dense that nuclear fusion ignited for the very first time. And then, after hundreds of millions of years of silence, the first stars were born. The appearance of those first stars changed the universe forever. These ancient stars were unlike many stars we see today. They were likely enormous, extremely hot, and incredibly bright. Because the early universe contained almost no heavy elements, these primordial stars burned differently from modern stars. Many may have lived only short cosmic lives before exploding as titanic supernovae. But during their brief existence, they illuminated the darkness for the first time. Imagine the first sunrise in cosmic history. For countless ages, space had remained dark and opaque. Then suddenly, brilliant blue-white stars ignited across the blackness like distant fires emerging in an endless night. Their light spread outward into regions that had never known illumination before. The universe was finally awakening. Astronomers call this transformative era cosmic dawn because it marked the moment when the cosmos transitioned from darkness into light. The first stars gathered into primitive galaxies, forming islands of radiance scattered through the young universe. Those early galaxies were much smaller and more chaotic than galaxies today, yet they became the foundations for everything that followed. Over billions of years, they merged, evolved, and grew into the majestic spirals and giant ellipticals we now observe across space. But cosmic dawn changed more than appearance alone. The first stars also transformed the physical nature of the universe itself. Before starlight emerged, neutral hydrogen gas absorbed much of the ultraviolet radiation traveling through space, making the universe foggy and opaque. As early stars emitted enormous amounts of energetic radiation, they began stripping electrons away from hydrogen atoms in a process called reionization. Slowly, the cosmic fog started to lift. Light could now travel farther through space. Regions once hidden became transparent. The universe opened itself to illumination. This process unfolded gradually across hundreds of millions of years. Vast bubbles of ionized gas expanded around newborn galaxies, overlapping and spreading through the cosmos. Eventually, much of the observable universe became transparent to ultraviolet light. The darkness was ending. Even today, scientists are still trying to fully understand this mysterious era. Powerful observatories search for faint signals from the universe's earliest galaxies. Telescopes peer billions of light years into space, which also means billions of years into the past. When astronomers observe extremely distant galaxies, they are witnessing ancient light that began its journey long before Earth even existed. Some of the faintest galaxies ever detected appear as tiny red smudges hidden deep within telescope images. Yet those fragile points of light represent the beginning of cosmic structure itself. They are ancient survivors from the universe's first awakening. Modern instruments like the NASA James Webb Space Telescope are helping scientists study cosmic dawn in unprecedented detail. By detecting infrared light from extremely distant galaxies, astronomers can explore periods closer to the Big Bang than ever before. Every new discovery helps piece together the story of how darkness transformed into light. And perhaps the most beautiful part of this story is realizing that cosmic dawn eventually made life possible. The first stars forged the earliest heavy elements inside their cores. When those stars died in violent explosions, they scattered carbon, oxygen, iron, and other elements across space. Later generations of stars formed from this enriched material. Around some of those stars, planets emerged. Eventually, on at least one small planet orbiting an ordinary star, living organisms appeared. Everything familiar to us traces back to those first ancient stars. The calcium in your bones, the oxygen you breathe, the iron flowing through your blood, all originated in stellar furnaces, ignited during the universe's long evolution after cosmic dawn began. In a very real sense, the first stars helped make your existence possible. Tonight, while you rest beneath the quiet sky, the light from ancient galaxies still travels endlessly across the cosmos. Some of it began its journey billions of years ago, during the universe's earliest luminous chapter. The darkness that once filled the universe is gone now. In its place are galaxies, stars, planets, oceans, clouds, forests, cities, and living minds capable of wondering about the cosmos itself. And somewhere out there tonight, far beyond the reach of human eyes, new stars are still quietly igniting in the dark. Every night, when you look up at the stars, you are not seeing the universe as it is now. You are seeing fragments of the past. The moon appears as it looked about 1 second ago, because light needs time to travel from its surface to Earth. The sun we see glowing in the sky actually belongs to the past as well. Its light takes around 8 minutes to reach us. If the sun were to somehow disappear this instant, humanity would continue seeing its warm golden light for 8 more minutes before darkness arrived. Light is incredibly fast, moving at nearly 300,000 kilometers every second. And yet the universe is so vast that even light requires years, centuries, or billions of years to cross it. This transforms the cosmos into something extraordinary. It means space itself has become a natural time machine. Every time astronomers look deeper into space, they are also looking farther into the past. The nearest star system beyond our own, Alpha Centauri, lies more than 4 light years away. The light entering telescopes tonight began its journey before many children currently alive were even born. More distant stars reveal even older moments in time. Some galaxies are so far away that their light started traveling toward Earth before human civilization existed. Others began their journey before Earth itself had fully formed. The deeper scientists peer into the cosmos, the closer they move toward the beginning of time itself. This is one of the most astonishing truths in astronomy. Unlike historians, astronomers do not rely only on ancient artifacts or written records to study the past. The universe preserves its own history directly in light. Every beam of starlight carries information about where it came from and when it began traveling. Light becomes a messenger from another era. When astronomers study distant galaxies, they are witnessing those galaxies exactly as they existed billions of years ago. Some appear young, chaotic, and irregular because their light originated during the universe's early stages of development. Scientists can literally observe galaxies growing and evolving across cosmic time. Nearby galaxies often appear mature and stable. Faraway galaxies appear ancient and primitive. Together, they create a timeline stretching across the history of the universe. This ability allows humanity to investigate events that happened long before Earth existed. Telescopes can observe ancient explosions, early star formation, and even the faint afterglow left behind by the Big Bang itself. In some sense, the night sky is filled with ghosts of ancient moments, still traveling endlessly through space. Even the stars above your head tonight may no longer look exactly the same as the light you see from them now. Some stars may have changed dramatically since their light first began its journey toward Earth. A few distant stars visible in the sky may have already died, their final explosions still racing silently through the cosmos, not yet reaching us. The universe we observe is always slightly delayed. We never see reality exactly as it is in the present moment. We only see echoes of what once was. This delay becomes even more fascinating when observing extremely distant galaxies. Because the universe itself expands while light travels through it, ancient light stretches into longer wavelengths over billions of years. Visible light gradually shifts into infrared light during its immense journey across expanding space. That is why powerful infrared telescopes are so important for studying the early cosmos. The NASA James Webb Space Telescope was designed specifically to observe this ancient, stretched light. By detecting faint infrared signals from the distant universe, it can peer farther back in time than previous telescopes. Some of the galaxies observed by Webb existed only a few 100 million years after the Big Bang. That means the telescope is capturing light nearly as old as the observable universe itself. When scientists release these deep-field images, they often appear peaceful and beautiful. Tiny glowing galaxies scatter across blackness like grains of golden dust. But each small point of light represents something enormous. Entire galaxies, containing billions of stars, separated by unimaginable distances. And every one of them is part of the universe's long memory. The farther away an object lies, the older its light becomes. In this way, distance and time become intertwined across the cosmos. Looking outward through space also means looking backward through history. No human-built archive could ever compare to this cosmic record. The universe stores its own story within traveling light. Even the cosmic microwave background radiation acts like a photograph from infancy itself. This faint radiation filling all space comes from a time when the universe was only about 380,000 years old. Before then, space was too dense and hot for light to travel freely. But once the universe cooled enough, photons were finally released to journey across the cosmos. Those same ancient photons still surround you tonight. Invisible relics from the birth of time continue passing quietly through your room, through your body, and through Earth itself. Instruments sensitive enough can detect them. Human beings have learned how to hear whispers from nearly 14 billion years ago. Perhaps that is what makes astronomy feel so deeply emotional sometimes. When we gaze into the universe, we are not merely observing distant objects. We are witnessing layers of history unfolding simultaneously before our eyes. Every star becomes a memory. Every galaxy becomes a chapter from another cosmic age. The night sky is alive with ancient journeys still unfinished. And despite all our technological advances, there are still limits to how far we can see. Because the universe has a finite age, there exists a cosmic horizon beyond which light has not yet had enough time to reach us. Beyond that invisible boundary may lie countless more galaxies, stars, and mysteries forever hidden from view. The observable universe is vast beyond comprehension, yet it may only be a small portion of an even greater reality. Still, within the light we can observe, humanity has uncovered an extraordinary truth. The cosmos is not frozen in time. It is moving, changing, evolving, and remembering. Tonight, as you rest quietly beneath the stars, ancient light continues arriving from every direction. Some of it began traveling long before Earth existed. Some began before the Milky Way fully formed. Some may have started its journey near the dawn of galaxies themselves. And somehow, after crossing billions of years of darkness, that ancient light finally reaches your eyes. For a brief moment, the universe allows you to see its past. There are invisible forces flowing through the universe right now. Silent currents drifting between stars, hidden structures stretching across entire galaxies, magnetic rivers so enormous that they span tens of thousands of light years through space. And yet no human eye could ever see them directly. Entire galaxies are threaded with invisible magnetic fields that quietly shape the movement of gas, cosmic rays, and interstellar matter. These magnetic structures weave through spiral arms like unseen currents flowing beneath the surface of a cosmic ocean. Although they remain largely invisible, their influence reaches across the universe in profound and beautiful ways. On Earth, magnetic fields already feel mysterious enough. Our planet's magnetic field quietly protects life by deflecting dangerous charged particles from the sun. Without it, Earth's atmosphere might have been stripped away long ago by solar winds. Compasses respond to this invisible force. Auroras dance because of it. Electric storms interact with it. But the magnetic fields drifting through galaxies are vastly larger than anything we experience on Earth. They stretch across incomprehensible distances. Inside galaxies like the Milky Way, magnetic fields thread through clouds of gas and dust, guiding charged particles through space almost like cosmic highways. These fields influence how matter moves, how stars form, and even how galaxies evolve over billions of years. Without magnetic fields, the universe might look very different. For a long time, scientists barely understood that galactic magnetic fields even existed. Since magnetic fields cannot be seen directly, astronomers had to discover clever ways of detecting them. One important method involves observing how magnetic fields affect light traveling through space. As radio waves move through magnetized regions filled with charged particles, the orientation of the waves subtly twists. By studying these distortions, astronomers can map otherwise invisible magnetic structures drifting through galaxies. Slowly, a hidden universe began to reveal itself. What scientists discovered was astonishing. Many spiral galaxies contain enormous magnetic patterns that align beautifully with their spiral arms. These invisible fields curve gracefully through interstellar space, following the overall structure of the galaxy itself. Some resemble giant cosmic whirlpools. Others form tangled webs shaped by turbulence, star formation, and galactic rotation. Even though galactic magnetic fields are extremely weak compared to a refrigerator magnet or Earth's own magnetic field, their influence becomes significant because they extend across such enormous distances. Their scale gives them power. Inside giant molecular clouds where stars are born, magnetic fields help regulate the collapse of gas. Gravity constantly tries to pull material inward, compressing clouds until fusion ignites inside newborn stars. But magnetic pressure can partially resist this collapse, slowing the process and shaping how stars emerge. In this way, invisible magnetic forces help determine where stars are born and how galaxies grow. The night sky itself has been quietly sculpted by forces no human can see. Magnetic fields also guide cosmic rays through space. Cosmic rays are high-energy particles traveling near the speed of light, often produced by violent cosmic events like supernova explosions or black hole jets. Instead of moving in perfectly straight lines, many of these particles spiral along magnetic field lines, threading through galaxies. The galaxy becomes filled with invisible pathways, directing energetic particles across interstellar space. Even our own solar system drifts through this magnetized cosmic environment. The sun generates its own magnetic field as well, constantly changing and twisting through solar storms and eruptions. During periods of intense solar activity, magnetic disturbances can trigger spectacular auroras on Earth, filling polar skies with glowing curtains of green and red light. Those shimmering lights are reminders that invisible magnetic forces surround us constantly. And on larger scales, galaxies themselves participate in similar unseen interactions. Some astronomers believe magnetic fields may even help shape the vast cosmic web connecting galaxies across the universe. Between galaxies lies diffuse gas threaded with faint magnetism stretching through intergalactic space. Although incredibly weak, these immense magnetic structures may influence how matter flows across cosmic filaments over billions of years. The universe may be far more interconnected than it first appears. One of the greatest mysteries is how these magnetic fields first formed. Scientists still debate their ultimate origin. Perhaps tiny primordial magnetic fields emerged shortly after the Big Bang itself, later amplified as galaxies formed and rotated. Or perhaps magnetic fields arose gradually from the motion of charged particles inside early stars and galaxies. No one knows for certain. But somehow, across billions of years, magnetism became woven into the fabric of cosmic evolution. Even black holes interact dramatically with magnetic fields. Around supermassive black holes lurking at galactic centers, swirling disks of superheated gas generate intense magnetic activity. These magnetic forces can help launch colossal jets of particles traveling near light speed across millions of light years. Invisible magnetic fields help power some of the most energetic phenomena in existence. And yet, despite all this complexity, the universe carries out these processes in almost complete silence. No sound echoes through space. No warning announces the movement of magnetic rivers between the stars. Entire galaxies evolve beneath invisible forces drifting quietly through darkness. Tonight, as you rest beneath the sky, you are surrounded by magnetism as well. Earth's magnetic field stretches far into space, forming a protective bubble around our planet called the magnetosphere. Beyond it lies the sun's magnetic influence. Beyond that, the magnetic environment of the Milky Way itself. You are floating inside layers of invisible cosmic structure. Perhaps that is one of the strangest and most beautiful truths about the universe. Some of its most powerful forces cannot be seen directly at all. Gravity shapes galaxies invisibly. Dark matter remains hidden. Magnetic fields drift silently through interstellar space. The cosmos is filled with unseen architecture, quietly guiding the evolution of stars, planets, and galaxies across unimaginable spans of time. And somewhere tonight, deep inside distant spiral galaxies, glowing softly in the dark, invisible magnetic rivers continue flowing between the stars. Right now, as you rest beneath the quiet glow of distant stars, an invisible storm is passing through the world around you. Not a storm of wind or rain, but a storm made of particles so tiny and energetic that trillions of them move through Earth's atmosphere every second without being seen. Some were born in exploding stars long before the Earth existed. Others may have been launched from the violent surroundings of black holes far beyond our galaxy. They travel across unimaginable distances at nearly the speed of light, silently crossing the vast darkness of space before finally reaching our tiny blue world. And even now, a few of these ancient travelers are gently passing through your body. The universe is never truly still. Even in the calmest silence of night, Earth remains immersed in an endless cosmic ocean of invisible radiation and energetic particles. These particles are known as cosmic rays, and despite their name, they are not actually rays of light. Most are tiny fragments of atoms, mainly protons and atomic nuclei, accelerated to astonishing speeds by some of the most violent events in the cosmos. For more than a century, cosmic rays have fascinated scientists because they carry messages from places humans may never reach. Long ago, before astronomers fully understood their origin, strange instruments detected mysterious radiation coming from above. In the early 1900s, physicist Victor Hess carried sensitive equipment high into the sky using hot air balloons. As he climbed higher into Earth's atmosphere, he discovered something unexpected. The radiation became stronger. If the radiation were coming from Earth itself, it should have weakened with altitude. Instead, the opposite happened. Hess realized the particles were arriving from outer space. His discovery opened a completely new window into the universe and revealed that Earth was constantly being bombarded by energetic visitors from the cosmos. Some cosmic rays begin their journey inside supernovas. When massive stars die, they explode with extraordinary violence, briefly shining brighter than entire galaxies. These explosions send shockwaves racing through space, accelerating particles to incredible speeds. Tiny fragments of matter are hurled outward like cosmic bullets, beginning journeys that may last millions of years before reaching another star system. Other cosmic rays are born near black holes. Around certain black holes, especially the supermassive ones hidden within galactic centers, enormous jets of charged particles erupt outward at nearly the speed of light. Magnetic fields twist and compress matter into colossal beams that stretch across millions of light years. Within these violent regions, particles gain energies far beyond anything humanity can create on Earth. And then they travel. They cross silent galaxies. They drift through cosmic filaments. They pass through magnetic fields and interstellar clouds. Eventually, after journeys longer than human civilization itself, a few arrive here. When cosmic rays collide with Earth's atmosphere, something beautiful and invisible occurs high above your head. The incoming particles smash into atoms in the upper atmosphere, creating enormous cascades of secondary particles called air showers. One single cosmic ray can trigger an entire chain reaction. Particles split into more particles, which collide again and again, creating a brief, invisible waterfall spreading through the sky. Some of these particles continue downward until they reach Earth's surface. Even now, tiny remnants of these cosmic collisions are quietly passing through buildings, oceans, forests, mountains, and people. Most pass harmlessly through you without leaving any trace. The human body exists within a constant rain of cosmic particles. And strangely, this is completely natural. Life on Earth evolved beneath this cosmic shower for billions of years. Earth itself helps protect us from the most dangerous radiation. Our planet's magnetic field acts like an invisible shield, deflecting many charged particles before they can reach the atmosphere. Without this protective magnetic cocoon, life on the surface might have struggled to survive. The atmosphere also serves as a protective blanket. By the time most cosmic rays reach the ground, much of their energy has already been absorbed high above us. Still, scientists continue studying cosmic rays because they offer rare clues about the universe's most extreme environments. Some cosmic rays possess energies so enormous that they challenge our understanding of physics itself. A single subatomic particle can carry more energy than a baseball traveling at professional pitching speed. Yet the particle itself is smaller than an atom. The universe can accelerate matter in ways humanity still struggles to explain. Cosmic rays also connect Earth to the broader rhythms of the solar system. The sun constantly releases streams of charged particles known as the solar wind. This solar wind interacts with incoming cosmic rays, sometimes shielding Earth from part of the cosmic bombardment. During periods of intense solar activity, the solar wind becomes stronger, changing how many cosmic rays can enter the inner solar system. In this way, the behavior of our own star subtly shapes the invisible cosmic weather surrounding Earth. Some scientists even wonder whether cosmic rays may influence cloud formation and climate patterns. When cosmic rays ionize molecules in the atmosphere, they can help create tiny charged particles that may act as seeds for cloud droplets. Clouds, in turn, affect how much sunlight Earth reflects back into space. While the full connection remains debated, it is fascinating to imagine that distant supernovas might subtly influence the skies above our planet. The cosmos may affect Earth in quieter ways than we once imagined. Far above the atmosphere, astronauts encounter cosmic rays much more directly. Outside Earth's magnetic shield, space becomes a far harsher environment filled with energetic radiation. Future missions to Mars and beyond must carefully consider how cosmic rays affect human health during long journeys through deep space. Even our exploration of the stars is shaped by these invisible travelers. Yet despite their immense energy, there is something strangely peaceful about cosmic rays. They remind us that the universe is connected. The atoms forged in ancient stars continue moving across unimaginable distances. Explosions that occurred millions of years ago still leave traces here tonight. Events unfolding near black holes in distant galaxies may send particles silently streaming across the cosmos long after civilizations rise and disappear. The universe is always in motion, even in darkness, even in silence. Right now, while you rest comfortably on this small world orbiting an ordinary star, particles from ancient cosmic catastrophes are still arriving after journeys across billions of miles. Tiny messengers from deep time continue falling gently through the atmosphere, like invisible cosmic rain. And somehow, within this endless movement of galaxies, radiation, gravity, and light, you are here. a quiet observer beneath the stars, connected to explosions older than humanity, connected to the silent rhythms of the cosmos itself. As the night grows softer and your thoughts begin to drift, the universe continues its endless journey above you. Cosmic rays keep flowing through the darkness. Stars continue exploding in distant galaxies. Black holes continue launching invisible storms across intergalactic space. And Earth continues floating peacefully through it all. There is a quiet and humbling possibility hidden within the night sky. Everything humanity has ever seen, every star, every galaxy, every black hole, every nebula glowing softly across the darkness. Even the most distant light ever detected by our telescopes may represent only a tiny fraction of what truly exists. Beyond the furthest reaches of observation, the universe may continue endlessly into depths we will never fully witness. And tonight, as you rest beneath the stars, you are floating inside only a small, visible island, surrounded by an ocean far greater than human imagination can comfortably hold. The observable universe feels enormous to us. It contains hundreds of billions of galaxies scattered across unimaginable distances. Light itself, traveling at nearly 300,000 kilometers per second, requires billions of years to cross these cosmic expanses. The nearest large galaxy, Andromeda, lies more than 2 million light-years away. Some galaxies we observe tonight emitted their light before Earth even existed. Yet despite all this immensity, there is a boundary to what we can see. This limit is not created by walls or edges in space. It exists because the universe has a finite age. The cosmos began approximately 13.8 billion years ago, and light travels at a finite speed. That means there has only been a limited amount of time for light to cross space and reach us. No matter how powerful our telescopes become, we can observe only regions whose light has had enough time to arrive since the beginning of cosmic history. This creates what scientists call the cosmic horizon. Beyond that horizon lies darkness, not because nothing exists there, but because its light has not yet reached us. Perhaps it never will. As space itself expands, some distant regions move away faster than light can bridge the gap. Their ancient photons may spend eternity traveling without ever arriving at Earth. Entire galaxies could exist forever beyond human observation, permanently hidden from view by the expansion of the universe itself. The cosmos may therefore be vastly larger than the observable universe. What we call the universe is often simply the portion we can detect. But beyond that visible bubble, space may continue for unimaginable distances. Some cosmologists believe the universe could even be infinite, stretching endlessly in every direction, without edge or boundary. An infinite universe is difficult for the human mind to grasp. Our lives are built around limits. Rooms have walls, oceans have shores. Even planets and stars possess clear shapes and boundaries. But infinity offers no edge to arrive at. No final destination. No outer wall where space suddenly ends. If the universe truly extends forever, then galaxies continue beyond our horizon endlessly, forming cosmic structures farther than any future civilization could ever travel. And perhaps somewhere unimaginably distant, other stars shine upon worlds no human being will ever know. This mystery becomes even more profound when we consider how small the observable universe already is compared to the whole. Imagine standing on a beach at night beside a vast, dark ocean. The small circle illuminated by your flashlight represents everything humanity can observe. Beyond the edge of that light lies an enormous, unseen expanse hidden in darkness. That may be a relationship to the cosmos itself. Modern cosmology suggests that during the universe's earliest moments, a brief event called cosmic inflation caused space to expand extraordinarily fast. In a tiny fraction of a second, the universe ballooned from microscopic scales to enormous cosmic dimensions. AT is proportional to e to the power of HT. This rapid expansion may have stretched the universe far beyond the regions we can currently observe. The observable cosmos could therefore be only one small patch inside a vastly larger structure produced during inflation. Some theories even suggest inflation may still occur elsewhere. In these ideas, separate regions of space could continuously form their own cosmic expanses, each with different properties, laws, or histories. This concept, sometimes called the multiverse, remains speculative. but it reflects how modern cosmology increasingly points toward realities larger and stranger than earlier generations imagined. And yet, despite all this vastness, the night sky often feels intimate, perhaps because light connects us to distant things. When you look upward, you are not merely seeing stars, you are seeing time itself. Ancient photons that traveled across billions of years are gently entering your eyes tonight. Some began their journey long before mountains rose on Earth. Some departed their galaxies before the first animals walked across our planet. The universe allows us to witness fragments of its ancient history through light. But beyond the cosmic horizon, there are places whose stories remain forever untold to us. There may be galaxies where civilizations rise and vanish without their light ever touching Earth. Entire cosmic structures may drift eternally beyond observation, hidden behind the limits of time and expansion. This realization can feel both lonely and beautiful. Humanity often longs to understand everything, yet the cosmos reminds us that mystery itself may be permanent. There may always be regions beyond knowledge, horizons beyond reach, and truths hidden within distances too vast for light to cross. But perhaps this mystery is part of what makes the universe feel so alive. The unknown keeps the cosmos open and unfinished. Every generation of astronomers has discovered that reality is larger than previously believed. Ancient civilizations thought Earth stood at the center of existence. Later we learned Earth orbits the Sun. Then we discovered the Sun is only one ordinary star inside the Milky Way. Soon after, we realized our galaxy itself is merely one among billions. Each discovery expanded the scale of existence, and still the horizon keeps moving farther away. Even the observable universe continues growing as ancient light finally reaches us after billions of years. Every year, humanity sees slightly farther into cosmic history than before. Telescopes like the James Webb Space Telescope reveal galaxies from astonishingly early epochs, allowing us to glimpse the universe when it was still young and forming its first structures. Yet with every answer comes even larger questions. What exists beyond the observable edge? Does space continue forever? Will humans ever understand the true shape of the cosmos? Or are we destined to forever float within a small, illuminated bubble, surrounded by infinite, unseen darkness? Tonight, as you rest quietly on this small, rotating world, it is comforting to remember that you are part of something immeasurably vast. The atoms within your body belong to a universe far older and larger than human thought can fully contain. Your existence unfolds inside a cosmic story still expanding, still evolving, still filled with mysteries beyond the horizon. And somewhere beyond the furthest galaxies we can observe tonight, space itself may continue endlessly into silence. An unseen ocean of stars, a hidden architecture of galaxies, a cosmos larger than anything we may ever know. Yet even within this immense mystery, here you are, awake beneath the ancient sky, a small conscious moment inside an endless universe quietly unfolding through time. There was a moment when the entire universe changed faster than anything we can truly imagine. Not over millions of years, not even over seconds, but within a tiny fraction of a second, after the beginning of time itself. In that almost impossible instant, the newborn universe expanded faster than light, stretching from something unimaginably small into a cosmos vast enough to eventually contain galaxies, stars, planets, oceans, and you. Tonight, as you rest beneath the quiet darkness of space, it is astonishing to realize that everything around us may exist because of one explosive burst of expansion that happened long before the first atom fully formed. This event is known as cosmic inflation, and although it lasted for only the briefest moment, inflation may have shaped the entire structure of the universe we see today. Before inflation, the universe was incredibly tiny, dense, and hot. Space itself was compressed into a state beyond anything human experience can compare to. The laws of physics as we understand them begin to blur under such extreme conditions. Time, matter, energy, and space were all intertwined within a realm of extraordinary intensity. Then, suddenly, the universe expanded. Not like an explosion moving outward into empty space, but rather space itself stretched everywhere at once. Every tiny region became enormously larger almost instantly. Distances that were once smaller than atoms expanded to cosmic scales in less than a heartbeat. AT is proportional to e to the power of ht. This expansion happened so rapidly that regions of space moved apart faster than the speed of light. Surprisingly, this does not violate Einstein's theory of relativity, because objects were not moving through space faster than light. Instead, space itself was expanding. It is a subtle but profound difference. Imagine drawing tiny dots on the surface of a balloon. As the balloon inflates, the dots move farther apart, even though they are not actively traveling across the surface themselves. During inflation, the universe behaved somewhat similarly, except on scales beyond ordinary comprehension. This brief expansion helps explain one of cosmology's great mysteries. When astronomers observe the universe in every direction, it appears remarkably smooth and uniform on large scales. The ancient glow of the cosmic microwave background has nearly the same temperature everywhere, even in regions so distant they should never have exchanged information or energy. Without inflation, this uniformity becomes difficult to explain. But if the universe once existed in a much smaller, connected state before rapidly expanding, then those distant regions were once close enough to share the same conditions. Inflation stretched this smoothness across immense cosmic distances, creating the large-scale uniformity we observe today. At the same time, inflation also preserved tiny imperfections. Within the microscopic quantum world, tiny fluctuations constantly appeared and disappeared. Normally, these fluctuations would remain unimaginably small, but inflation stretched them outward to enormous scales. The smallest ripples became cosmic structures. Tiny variations in density eventually grew into galaxies, clusters, and vast cosmic filaments through the pull of gravity over billions of years. Everything humanity sees in the night sky may trace its origins back to microscopic quantum fluctuations, magnified during inflation. The stars above you tonight were once tiny ripples hidden within the newborn universe. Even the Milky Way itself began as a nearly invisible variation in density, smaller than an atom. And somehow, across cosmic time, those minute differences evolved into planets, oceans, forests, cities, and conscious minds capable of wondering about the universe that created them. Inflation connected the quantum world to the largest structures in existence. It linked the unimaginably small with the unimaginably vast. This idea remains one of the most elegant discoveries in modern cosmology because it explains so many features of the universe at once. It accounts for the universe's smoothness, its geometry, and the origin of cosmic structure. Yet inflation also raises profound mysteries. What caused inflation to begin? Why did it stop? What existed before it? Scientists still search for answers. Some theories suggest inflation may emerge naturally from quantum fields permeating space itself. Others propose that inflation could continue eternally in distant regions of the cosmos, constantly creating new universes beyond our observable horizon. In these models, our universe may be only one bubble inside a much larger cosmic reality. An endless inflationary sea producing countless regions of space and time. Though speculative, these ideas reveal how inflation continues pushing the boundaries of human understanding. Even today, scientists search for traces of inflation hidden within ancient light. The cosmic microwave background radiation, the faint afterglow of the Big Bang, preserves subtle patterns left behind by the earliest moments of cosmic history. Tiny temperature variations and delicate polarization signals may contain evidence of inflation's violent expansion. Space observatories and telescopes carefully study these ancient imprints, searching for clues about the universe's first instant. In a way, the cosmos still remembers its own birth. And tonight, that ancient memory surrounds you. Every atom in your body formed within a universe shaped by inflation. Every galaxy drifting across the cosmic web owes its existence to that extraordinary expansion at the dawn of time. Without inflation, the universe might look completely different. Perhaps galaxies would never have formed. Perhaps stars would never ignite. Perhaps no planets or life would exist at all. The quiet room around you tonight may ultimately trace its existence back to one tiny moment when space itself suddenly expanded beyond imagination. And there is something strangely peaceful about that thought. The universe began not with order fully formed, but with energy, motion, and possibility. From chaos emerged structure. From microscopic fluctuations emerged galaxies. From ancient stars emerged the elements of life. And from the unfolding of cosmic history emerged you, a conscious being capable of looking upward and wondering how existence began. As the night grows quieter and your thoughts drift softly through the cosmos, imagine the infant universe expanding in silence beyond comprehension. Tiny ripples stretch across newborn space. Ancient light begins its endless journey. The first seeds of galaxies quietly take shape within the darkness. The universe is still expanding even now. Galaxies continue drifting farther apart as space slowly grows larger with time. The process that began during inflation left the cosmos forever changing, forever unfolding. And somewhere deep within the ancient structure of the universe, the echoes of that first impossible expansion still remain. Thank you for spending this quiet moment among the stars tonight. Subscribe if you'd like more peaceful cosmic journeys before sleep. There are places in the universe where the darkness becomes almost unimaginable. Not the ordinary darkness between stars, not even the quiet emptiness between galaxies, but enormous regions so vast and empty that a galaxy could drift through them for millions of years without ever encountering another galactic neighbor. These immense expanses are known as cosmic voids, and they are among the loneliest places in existence. Tonight, as you rest comfortably beneath the stars, it may feel impossible to imagine true emptiness. Earth is alive with oceans, mountains, wind, light, and sound. Even space itself often appears crowded in telescope images, filled with glittering galaxies and luminous nebulae scattered across the heavens. But the universe is not evenly filled with matter. On the largest scales, the cosmos resembles a colossal web. Galaxies gather along gigantic filaments stretching across hundreds of millions of light years. Clusters of galaxies form glowing intersections where these filaments meet, creating enormous cosmic cities filled with stars and hot gas. Yet between these luminous structures lie the voids, vast regions where very little exists at all. If you could somehow travel into one of these cosmic voids, the universe would appear eerily empty. The familiar glow of neighboring galaxies would fade into distant pinpoints barely visible against the darkness. The night sky itself would become quieter and darker than anything human beings have ever experienced. Some voids span hundreds of millions of light years across. To grasp their scale, remember that light itself travels nearly 300,000 kilometers every second and still requires millions of years to cross even a small fraction of these regions. Entire civilizations could rise and vanish while a beam of light slowly drifts across a single cosmic void. And still, the emptiness continues. The existence of voids reveals something profound about how the universe evolved. In the early cosmos, matter was distributed almost uniformly after the Big Bang, but tiny fluctuations in density existed throughout space. Over billions of years, gravity slowly amplified those differences. Regions containing slightly more matter pulled in surrounding gas and dark matter, eventually forming galaxies, clusters, and filaments. Meanwhile, the emptier regions lost matter to their denser surroundings. The rich became richer. The empty became emptier. Gradually, enormous voids emerged between the growing structures of the cosmic web. In some ways, the universe organized itself into a balance between crowded regions and immense silence. And yet, despite appearing empty, cosmic voids are not completely devoid of matter. A few lonely galaxies still drift within them. Thin wisps of gas and traces of dark matter quietly linger in the darkness. Faint radiation crosses these vast expanses. Invisible neutrinos stream silently through them. Quantum fields still permeate space itself. Even the emptiest places in the universe are not truly nothing, but compared to the bustling clusters of galaxies elsewhere, voids are astonishingly barren. Imagine standing inside a galaxy located deep within one of these regions. The nearest major galaxy might lie tens of millions of light years away. Civilizations living there, if any exist, could gaze outward and see a dramatically different cosmos from our own. They might not even realize the true richness of the universe beyond their isolated environment. Their skies would appear quieter, lonelier, perhaps even eternal in their emptiness. Cosmic voids also influence the movement of galaxies around them. Although voids contain little matter, their very emptiness affects gravity on enormous scales. Surrounding galaxies gradually move away from voids toward denser regions of the cosmic web. In this way, the emptiness itself helps shape the architecture of the universe. The voids quietly guide cosmic motion, like invisible valleys between mountains of galaxies. Astronomers study these immense empty regions because they offer unique clues about dark energy, gravity, and cosmic evolution. Since voids are relatively simple environments, with fewer galaxies and less chaotic activity, they provide important laboratories for understanding how the universe expands over time. Some scientists even use voids to test theories about the nature of gravity itself. The emptiest places in existence may help reveal the deepest truths about the cosmos. And there is something strangely peaceful about them. Human beings often fear emptiness. Silence can feel unsettling. Loneliness can seem cold and infinite. Yet cosmic voids possess a quiet beauty unlike anywhere else in the universe. They remind us that the cosmos is not only made of stars and light, it is also shaped by absence. The spaces between galaxies matter just as much as the galaxies themselves. Without emptiness, the cosmic web could not exist. Without the silent voids, the universe would not possess its breathtaking, large-scale structure. Even in music, silence gives meaning to sound. Perhaps the universe follows a similar rhythm. Light and darkness, matter and emptiness, galaxies and voids. Together, they create the grand cosmic landscape through which Earth quietly drifts tonight. And still, these voids continue growing. As the universe expands, galaxies move farther apart, and the large-scale structure slowly evolves. Over unimaginable stretches of time, many galaxies beyond our local cosmic neighborhood may eventually disappear from view entirely, as space expands faster and faster. Future civilizations trillions of years from now may inhabit a universe far darker and emptier than the one we know today. The cosmos itself may gradually become more isolated, more silent, more void-like. Yet here, now, humanity exists during an extraordinary era when countless galaxies still illuminate the night sky. We live at a time when the universe remains richly visible, filled with ancient light arriving from distant cosmic shores. And tonight, while you rest on this small world orbiting an ordinary star, immense voids continue stretching silently across the universe beyond imagination. Regions where darkness reigns for hundreds of millions of light years, places where lonely galaxies drift through nearly empty space like isolated islands floating upon a black cosmic sea. Yet somehow even these vast voids are part of the same universe that created oceans, forests, mountains, and human thoughts. The same cosmic evolution that formed galaxies also formed emptiness. And within that balance of light and silence, existence continues unfolding. As your thoughts slowly drift toward sleep, imagine the universe from far above. Luminous filaments glow softly across the darkness, while enormous voids rest quietly between them like tranquil cosmic oceans. Silent, ancient, endless. And somewhere within that immense cosmic web, Earth glows gently beside an ordinary star, carrying life peacefully through the darkness. Long before stars illuminated the darkness, before galaxies spiraled across the heavens, before planets, oceans, or life itself existed, the universe was already filled with an endless storm of invisible travelers. At this very moment, trillions of tiny particles are silently passing through your body. They move through your skin, your bones, your walls, even the entire Earth itself, almost as if matter were nothing at all. You cannot feel them, you cannot see them, and yet they are everywhere. These mysterious particles are called neutrinos, tiny ghost-like messengers born in some of the most violent and ancient events in cosmic history. They drift through the universe at nearly the speed of light, crossing unimaginable distances completely unnoticed. Most neutrinos will never interact with anything. A neutrino could pass through light years of solid lead without ever colliding with a single atom. That is how strangely elusive they are. And still, they may carry some of the deepest secrets about the birth of the universe itself. The story of neutrinos begins in the first seconds after the Big Bang, In those unimaginably early moments, the newborn universe was hotter and denser than anything we can truly comprehend. Matter and energy existed in a swirling sea of particles colliding constantly in every direction. Temperatures were so extreme that ordinary atoms could not exist yet. Inside this violent cosmic ocean, neutrinos formed in enormous numbers. For a brief period, they interacted frequently with other particles around them. But as the universe expanded and cooled, space itself began stretching rapidly outward. The density of matter dropped. Collisions became less common. Then something extraordinary happened. The neutrinos escaped. Only about 1 second after the birth of the universe, these particles decoupled from matter and began freely streaming across the cosmos. And they have never stopped traveling since. Even now, ancient relic neutrinos from the dawn of time may still surround us like an invisible cosmic fog. Unlike light, which remained trapped for hundreds of thousands of years before finally escaping as the cosmic microwave background, neutrinos slipped free almost immediately after the Big Bang. That makes them among the oldest messengers in existence. In a way, neutrinos are time travelers, carrying whispers from the universe's first heartbeat. But detecting them is incredibly difficult. Because neutrinos interact so weakly with matter, scientists must build enormous underground observatories hidden beneath mountains, deep ice, or vast underground caverns. These facilities shield delicate instruments from other particles and radiation, allowing researchers to search for the faintest signs of neutrino interactions. Sometimes, after traveling for billions of years through silent intergalactic darkness, a single neutrino finally collides with an atom inside one of these detectors. For a brief instant, light flashes, a tiny signal appears, and from that tiny signal, scientists can learn about exploding stars, black holes, nuclear reactions, and even the early universe itself. One of the most fascinating things about neutrinos is that they come from so many different cosmic sources. The Sun produces enormous numbers of them every second through nuclear fusion deep within its core. Supernovas release floods of neutrinos when massive stars collapse and explode. Black hole jets may accelerate particles that eventually create high-energy neutrinos traveling across the universe. Even radioactive elements inside Earth quietly produce neutrinos beneath our feet. The universe is alive with these invisible travelers. And yet humanity remained completely unaware of them for most of history. The discovery of neutrinos emerged from a mystery. Scientists studying radioactive decay noticed something strange. Energy seemed to disappear during certain reactions, violating one of physics' most important laws. To solve this puzzle, physicist Wolfgang Pauli proposed an invisible particle carrying away the missing energy. At first, the idea sounded almost impossible. A particle with almost no mass, no electric charge, and barely any interaction with matter, it seemed absurd. But decades later, neutrinos were finally detected, and slowly scientists realized these ghost particles were not merely curiosities. They were fundamental pieces of cosmic reality. Today, neutrinos help researchers study some of the universe's most energetic and distant phenomena. Unlike light, neutrinos can travel through dense regions of space that photons cannot escape. They pass through exploding stars, galactic cores, and clouds of gas almost unhindered. This means neutrinos allow us to observe places otherwise hidden from view. In 1987, astronomers witnessed a nearby supernova known as SN 1987A. Before the visible light from the explosion fully reached Earth, detectors captured a burst of neutrinos arriving first. Those particles had escaped directly from the collapsing core of the dying star. For the first time, humanity had detected neutrinos from a supernova beyond our solar system. It was like hearing the heartbeat of a star as it died. And still, neutrinos continued to surprise scientists. For many years, researchers believed neutrinos had no mass at all, but experiments later revealed that neutrinos can actually change between different forms while traveling. This strange behavior, called neutrino oscillation, could only happen if they possess at least a tiny amount of mass. That discovery transformed modern physics. Even now, many mysteries remain unresolved. Scientists still do not fully understand why neutrinos have such small masses. Some researchers suspect they may help explain why matter exists at all. In the early universe, tiny imbalances between matter and antimatter may have allowed galaxies, stars, planets, and eventually life to survive. Neutrinos could be connected to that imbalance. Without it, the universe might have become a lifeless sea of radiation, with no galaxies, no oceans, and no human beings gazing at the stars. In quiet moments like this, it is astonishing to realize how deeply connected we are to these invisible particles. Every second, relic neutrinos from the dawn of the cosmos stream silently through your body. Particles born before stars existed continue their endless journey through space and time. You are surrounded by ancient messengers older than every galaxy in the night sky. And yet the universe remains calm. The stars continue glowing softly across unimaginable distances. Galaxies drift along invisible cosmic filaments. Black holes spin silently in the dark. And through it all, neutrinos move endlessly onward, like whispers from creation itself. Tonight, as you rest beneath the quiet sky, the universe is still speaking in invisible ways. Tiny particles born at the beginning of time continue passing gently through the world around you, carrying memories from an age before stars, before planets, before light itself filled the cosmos. And somewhere within that endless, silent flow, the story of the universe continues drifting softly through the darkness. Long after the first stars began shining across the darkness, the universe slowly transformed into a vast ocean of galaxies, drifting through space like luminous islands in an endless cosmic sea. But these galaxies were never truly still. Even now, while the night feels silent and unmoving around you, entire galaxies are traveling through the cosmos at incredible speeds. Some spin gracefully through space, others drift toward one another over billions of years. And somewhere in the distant darkness, countless galaxies are already beginning slow collisions that will reshape them forever. The universe is filled with motion so gradual that it unfolds almost beyond human imagination. Galaxies participate in an enormous cosmic dance. Unlike the sudden explosions or violent impacts we often imagine, galactic encounters happen with extraordinary slowness. Distances between stars are so vast that even when two galaxies collide, individual stars rarely crash directly into one another. Instead, gravity becomes the choreographer. Invisible gravitational forces stretch galaxies into elegant arcs, distort spiral arms into glowing streams, and pull vast rivers of stars across intergalactic space. Over millions and billions of years, galaxies begin reshaping each other in complete silence. If human eyes could witness time moving fast enough, the universe would look alive with flowing motion. Spiral galaxies would twist and sway. Streams of stars would unfurl like luminous ribbons. Massive galaxies would slowly consume smaller companions, drifting too close. And throughout this endless movement, gravity quietly sculpts the architecture of the cosmos. Our own galaxy, the Milky Way, is part of this dance. Surrounding the Milky Way are dozens of smaller satellite galaxies, slowly orbiting us through space. Some are already being stretched apart by tidal forces. Their stars spill outward into long stellar streams that wrap gently around our galaxy like ghostly trails of light. These streams are ancient remnants of galactic interactions still unfolding today. Far beyond them, another great participant approaches. The Andromeda Galaxy, our nearest large galactic neighbor, is traveling toward the Milky Way at over 100 kilometers per second. At first, this may sound terrifying, but the collision will not happen tomorrow, or even in thousands of generations. It will occur roughly 4 billion years from now, and when it finally begins, it will unfold so slowly that entire civilizations could rise and vanish before the galaxies fully merge. At first, Andromeda will simply appear larger in Earth's night sky. Over millions of years, its spiral arms will stretch across the heavens like glowing rivers of stars. Gradually, gravity will distort both galaxies. Vast clouds of gas will collide and compress, triggering enormous bursts of star formation. New stars will ignite across the merging galaxies like waves of cosmic fireflies. The shapes of both galaxies will begin changing completely. Their elegant spiral structures may eventually disappear, replaced by a giant elliptical galaxy born from the merger of two ancient stellar systems. And through it all, most stars will continue drifting peacefully through space without ever directly colliding. The scale of emptiness inside galaxies is almost impossible to comprehend. Even though galaxies contain hundreds of billions of stars, the distances separating them remain enormous. If our sun were the size of a grain of sand, the nearest star would still be many miles away. Space is mostly silence and emptiness. That vast emptiness allows galaxies to pass through one another like drifting clouds of light. Yet their gravity still transforms everything. These interactions shape how galaxies evolve across cosmic time. Some galaxies experience gentle encounters that merely stretch their spiral arms. Others endure violent mergers that completely alter their structure. Giant elliptical galaxies found in galaxy clusters are often the ancient remnants of countless past collisions. In a way, every galaxy carries scars and memories from earlier encounters. Astronomers can see evidence of these interactions everywhere. Some galaxies display long tidal tails extending far into space. Others contain warped disks, distorted shapes, or strange rings created by past gravitational encounters. Certain galaxies burn intensely, with rapid star formation, triggered by mergers compressing enormous clouds of gas. Even supermassive black holes at galactic centers may awaken during these interactions. As galaxies merge, gas falls inward toward their central black holes, feeding them enormous amounts of matter. This can ignite quasars, some of the brightest objects in the universe, producing powerful radiation and jets that influence entire galaxies. So even the quiet drifting of galaxies can awaken some of the most energetic phenomena in existence. On the largest scales, galaxies themselves follow invisible pathways shaped by the cosmic web. Gigantic filaments of dark matter stretch across the universe like hidden highways. Along these colossal structures, galaxies gather into clusters and superclusters, linked together through gravity. The cosmic dance is not random. Matter flows along ancient gravitational currents established billions of years ago, shortly after the Big Bang itself. Every galaxy's journey is part of a much greater pattern unfolding across the universe. And despite the unimaginable scale of these motions, the cosmos remains strangely peaceful. There are no sounds in the vacuum of space, no crashing thunder during galactic mergers, no roaring winds as billions of stars drift through intergalactic darkness. Only silence, a silent ballet unfolding over billions of years beneath the cold glow of ancient starlight. Sometimes astronomers observe galaxies caught in the middle of this dance. The antennae galaxies display enormous curved streams of stars pulled outward by tidal forces. The Whirlpool galaxy appears connected to a smaller companion whose gravity has helped shape its beautiful spiral structure. Across the observable universe, telescopes reveal countless examples of galaxies interacting, colliding, and transforming one another. These images are not snapshots of isolated objects. They are moments within an ongoing cosmic story, and humanity exists within that story too. Our solar system quietly orbits the center of the Milky Way at extraordinary speed. The sun carries Earth through space as the galaxy itself drifts among neighboring galaxies inside the local group. Even now, while you rest peacefully beneath the night sky, you are moving through the universe faster than you realize. Yet from our perspective, the stars appear calm and eternal. Perhaps that is one of the most beautiful things about the cosmos. Its greatest transformations happen slowly. The universe does not rush. Galaxies take billions of years to complete their dances. Stars live and die across incomprehensible stretches of time. Even light itself needs millions of years to cross the vastest structures in existence. Tonight, somewhere far beyond human sight, galaxies are already beginning new encounters. Gravity is stretching invisible bridges between stars. Ancient stellar systems are drifting closer together through silent darkness. New stars are being born inside glowing clouds compressed by cosmic tides. And throughout the universe, this endless dance continues quietly onward, a slow and beautiful choreography written by gravity itself, unfolding across the infinite ocean of space and time. Long before Earth formed beneath ancient skies, before oceans flowed across continents, before the first living cells quietly emerged in the darkness of the primordial sea, the atoms that would one day become you were already traveling through the universe. The calcium in your bones, the oxygen in your lungs, the iron flowing through your blood, all of it was forged inside stars that lived and died billions of years ago. You are not separate from the cosmos. You are part of its story. Every atom within your body carries a history older than mountains, older than Earth itself, perhaps even older than the sun. The universe has been quietly building the ingredients for life across unimaginable stretches of time, long before humanity ever gazed upward and wondered where it all began. In the earliest moments after the Big Bang, the universe was astonishingly simple. There were no planets, no galaxies, no oceans or forests or living creatures, only energy, expanding space, and the lightest elements beginning to form. Hydrogen emerged first, along with helium and tiny traces of lithium. These simple elements drifted through the young universe as gravity slowly gathered matter together. Over time, enormous clouds of gas collapsed inward, giving birth to the first stars. Those ancient stars transformed the cosmos forever. Deep within their blazing cores, nuclear fusion began creating heavier elements. Hydrogen fused into helium. Helium fused into carbon and oxygen. Massive stars continued forging increasingly complex elements through intense pressure and heat. For millions of years, these stars burned quietly in the darkness. Then, many of them died violently. When massive stars reached the end of their lives, they exploded as supernovas, releasing unimaginable amounts of energy. In those final catastrophic moments, even heavier elements formed. Iron, gold, calcium, silicon, and countless others were blasted outward into interstellar space. The universe scattered the ingredients for future worlds. Those elements drifted through cosmic clouds for millions or even billions of years. Slowly, gravity gathered them once again into new stars and planetary systems. One of those systems eventually became our own. About 4.6 billion years ago, a giant cloud of gas and dust collapsed to form the sun and the planets orbiting around it. Tiny grains of ancient stardust collided and merged repeatedly, slowly building Earth itself. The rocks beneath your feet, the oceans covering the planet, the air moving through forests and mountains, all of it came from recycled remnants of long dead stars. Even the atoms inside your body participated in this extraordinary journey. Perhaps a carbon atom within you once drifted through the atmosphere of another world before Earth even existed. Maybe an iron atom in your blood formed inside a massive star that exploded before the Milky Way fully developed its spiral arms. The universe has been recycling matter endlessly across cosmic time. Nothing is truly isolated. Everything is connected through ancient cycles of creation and transformation. This realization changes the way many people see the night sky. The stars no longer feel distant or unrelated to us. Instead, they become part of our origin story. Humanity emerged from the same cosmic processes shaping galaxies, nebulae, and planets throughout the universe. Carl Sagan once famously said that we are made of star stuff. And in a literal sense, it is true. The universe became conscious enough to observe itself through living beings formed from its own ancient matter. When you breathe, atoms forged in stars move through your lungs. When your heart beats, iron created inside exploding suns carries oxygen through your blood. When you look into the night sky, the universe is observing its own history through your eyes. There is something deeply peaceful about that thought. So often, human life can feel small beneath the scale of the cosmos. Galaxies stretch across millions of light years. Black holes bend space-time itself. Cosmic history spans nearly 14 billion years. And yet, despite our smallness, we are still woven into that immense story. The same laws of physics shaping distant galaxies also guide the atoms within your body. The same gravity pulling galaxies together once gathered the cloud that formed Earth. The same ancient starlight crossing the universe tonight may eventually fall upon worlds not yet born. Everything is connected through time. Even the cycles of life on Earth reflect cosmic processes unfolding on much larger scales. Stars are born, evolve, and die. Galaxies merge and transform. Matter changes form continuously across the universe. Life itself participates in that same endless transformation. The atoms within you were once part of stars. One day, they will return to Earth and continue their journey in new forms. In this way, the cosmos is never static. It is always unfolding, always changing, always creating. And still, amid all this vast motion, there remains extraordinary quietness. Right now, somewhere far beyond our galaxy, stars are forming inside glowing nebulae. Invisible neutrinos drift silently through space. Black holes slowly consume matter at the centers of galaxies. Ancient light from the Big Bang continues crossing the universe after billions of years of travel. And here on Earth, beneath the same sky that watched over countless generations before us, you rest quietly within this cosmic ocean. Perhaps that is why astronomy feels so calming to many people. It reminds us that we belong to something larger than ourselves. The worries of a single day begin to soften when placed beside cosmic time. The universe has survived exploding stars, galactic collisions, and billions of years of change. And throughout it all, matter continued evolving into new forms of beauty. Tonight, your existence is part of that beauty too. You are the product of ancient stars, cosmic dust, gravity, time, and light, woven together across billions of years. The universe carried your atoms through stellar explosions, interstellar clouds, planetary formation, and the long history of life on Earth, until eventually they became you. A living piece of cosmic history, capable of wonder, capable of dreaming, capable of looking upward and feeling connected to the stars. And while the universe may appear vast and silent, perhaps it is not entirely cold or empty after all. Because within this immense darkness, conscious life emerged. Tiny, warm beings began asking questions about existence, about time, about galaxies, about where we came from. And those questions themselves are part of the universe's unfolding story. Tonight, as the stars continue their quiet motion above the sleeping world, the cosmos carries on exactly as it always has. Galaxies drift, ancient light travels onward, invisible particles stream silently through space, and somewhere within this endless cosmic sea, you exist for a brief, beautiful moment, connected to everything that came before. As the universe continues its endless quiet unfolding tonight, I hope you rest peacefully beneath the same ancient stars that created us all.